In our last video, we looked at simplifying rational expressions. Today, we're going to build upon our repertoire. We're going to take our knowledge of simplifying rational expressions, and now we're going to multiply and divide them. But we'll look at two examples with multiplication, and we'll look at two examples with division. Now, the good news is that when we're looking at multiplication and division of rational expressions, it very much follows the rules of multiplying and dividing fractions. So when I had something like this, let's say I did 2/3 times 3/4. My goal to multiply the fraction is to get it down to one fraction so they're both together, um, but simplified. Now, there's a few ways we can do this, but generally what we want to look to do first is to reduce something. So I can cross reduce the 3's, and I can cross reduce the 2 and reduce the 2 and the 4, making it 1/2. Now to multiply the fractions, I multiply the numerators together, and I multiply the denominators together. Now what you're going to see what we do next is much of the same thing, but with far more complicated expressions. So for instance, we might have 5x plus 10 all over 6x multiplied by 3x squared over x squared plus 4x plus 4. So my first step, just like when we did with simplification, look to see if I can factor anything. Can I take out a greatest common factor? And if I look at the upper left, it appears I can take a 5 out, leaving me with 5 times x plus 2. Can't really do anything with that denominator since it's a monomial. In the upper right, there's nothing I can do since it's still a monomial. And in the denominator over here, x squared plus 4x plus 4 will become x plus 2 times x plus 2. Just like we did up here when we're trying to reduce, we're looking to cross-reduce. I'm looking in the numerator and denominator, see if first of all, is there anything that immediately cancels, that there's the same thing in the top and the bottom? And I'm seeing that right here with the x plus 2, so those are gone. Now I want to look to reduce. So I don't think I can do anything more along this diagonal. I'm going to look along here, and I'm seeing right away the 6 and the 3 can reduce to 2 and 1. And the x squared, I can take an x out of both of those, leaving me with just 1, I guess. And then here, the squared goes away, just leaving us with x. So then I multiply. In the numerator, I've got a 5 times a 1x, that's 5x. In the denominator, I've got a 2 and an x plus 2, and so that's my product. I'm not going to go any further than that because eventually what we're going to be able to do is take these and solve them. And so as factored forms, they're much easier to work with. So this is going to be my final answer. Now, I'm not worrying about excluded values here because it doesn't really seem appropriate when we're doing multiplication. It's not really a rational expression. It's two that we're trying to combine. So we're not going to worry so much about the excluded values at this point. For number 2, we are going to factor, or sorry, not factor, we're going to multiply x squared minus 2x minus 3 over x squared minus 1 times x squared minus 7x plus 6 all over x squared minus 3x. So let's take a look. Looking to take out a GCF. If I can't, I'm looking to factor. There's no greatest common factor between these three terms. So it's going to factor, though, to x minus 3 times x plus 1. Directly beneath that, I've got x squared minus 1. Again, no greatest common factor, but it will factor to x minus 1 and x plus 1. In the numerator of the second fraction, no greatest common factor, but it factors to x minus 6 and x minus 1. And in the denominator, I do have a greatest common factor. X squared and negative 3x have an x in common. When I take that out, I've got x times x minus 3. Now, before I look to multiply, I'm going to cross cancel, cross reduce. So if I have an x minus 3 here, I've got another one here. And I see an x minus 1 in these. But there's one more factor I can cancel. I can cancel out these x plus 1s because they're directly on top of each other. Really what I'm looking for is in the end product, if I have something that would be in the numerator and denominator, then I can get rid of it. And so the only thing that's left is this x minus 6 and this x. And I can't go any further than that. You might be tempted to cancel the x's out. That doesn't work. One's a monomial, one's a binomial. You cannot cancel those out. All right, so that's multiplication. Now let's think about division. So if I took a fraction, 2/3, and I divided it by, I don't know, let's do 2/5. The way we divide fractions is we actually turn that into a multiplication problem. So 2/3 divided by 2/5 will become 2/3 times 5/2. So notice when I'm turning that division into a multiplication, my second fraction, it's flipped. I'm going to take the reciprocal of that. Then I'll look to cancel and multiply, which would give me 5/3. What does this have to do with rational functions? Well, we're going to have problems that look like this. X plus 2 over x plus 4 all over x squared plus 6x plus 8 over x squared minus 16. And I swear I'm done with adding more fractions in this problem. But the problem that you're going to see here is that we have a fraction within a fraction. But that indicates to us that it's a division problem. But what we're going to do is rewrite this as a multiplication problem. X plus 2 over x plus 4, so I've left that numerator alone, times x squared minus 16 over x squared plus 6x plus 8. So I'm taking that second fraction and turning it into a multiplication by flipping it, finding the reciprocal. So I don't think I can do anything with here, x plus 2 and x plus 4. That just seems like there's really nothing to do there. But x squared minus 16 is factorable. X minus 4, x plus 4. X squared plus 6x plus 8 is factorable. X plus 4 and x plus 2. Looking to cross reduce, cross cancel. X plus 2 does cancel out, so that's going to leave me with a 1 there. And x plus 4 does cancel. That's going to leave me with a 1 there as well. So in the end, if I take 1 times x minus 4, that's x minus 4. In the denominator, I'm just going to be left with x plus 4. That is my final answer. All right, let's do one more. It's one that's got a little bit more complicated factor to it. So number 4, we are going to find 2x squared plus x minus 1 over 2x squared plus 3x minus 2, all divided by, big old mess, x squared minus 2x plus 1 over x squared plus x minus 2. Once again, we're going to turn that into a multiplication problem. So the numerator, I'm not going to do anything with it but copy it over. And the denominator, I'm going to flip it. So I'm looking for greatest common factor. I've got nothing to take out of both of anything. So I'm going to do my traditional factoring. So 2x squared, I know it's going to be a 2x and an x. And minus 1, so one of those has to be a positive 1 and a negative 1. I think I need to put the positive 1 here and the negative 1 here to get that middle term of x. In the denominator, I've got a 2x and an x. I think I see where this is going. This would be a plus 2 and a minus 1, which would give us that middle term of 3. In the numerator, x plus 2, x minus 1, and the denominator, x minus 1 times x minus 1. So cross-reducing, cross-canceling, x plus 1 doesn't cancel with anything there. X plus 2 cancels. Within the same fractions, I'm looking across those out and those out. So my final result then is x plus 1 over x minus 1. Once again, multiplying and dividing rational expressions is just like multiplying and dividing fractions. Just that we have that added step of factoring and then canceling some things out.